So, we were discussing about this example. In this example, we saw, all the sort of ingredients that we need for, basic ingredients that we need for our web applications, also for the exam. I mean, we're just missing authentication and this stuff. But I mean, here there are forms, there are interaction with the server, okay? The use of useEffect to handle these side effects, and basically that's what you need to write more complex applications, okay? Okay, good. So, what should we discuss now? Well, there are a few points that need a bit more attention, okay? I told you we are using two servers, and indeed one of your colleagues came during the break and told me, I tried to load something from the server for next lab and so on, which I already published, and I think, no, maybe not yet, but I mean, that's the same as last year's lab. And actually we are using, sorry, two web servers, and that's a problem. And we will discuss in more details about this problem next Monday, okay? This is called the course, and we will see what it means and so on. But in short, the browser imposes a number of limitations on what the initial page, in particular JavaScript inside that page, can do with the second server. What you do to the second server, I mean, the request that you send to the second server are called course request, that stands for cross origin resource sharing. So it goes to another server, in short, okay? So the browser is not so happy about this situation because, malicious code inside what you have received from the first web server could load stuff, making it appear coming from the first server, okay? And you don't even know that the browser, so the JavaScript is loading information from another server, okay? So this is a potentially a security issue. That's why I want to discuss this issue in more details with you next week. But I mean, at the moment, since we need a server to start playing a little bit with interaction with server, we just get rid of the problem with two simple lines on the server side, okay? So this is to be added on the server side. Of course, it's already there because I have the example working, okay? And so, in short, these two lines basically say browser, I mean, from the server we say, the first server, we say to the browser, please allow any course request. Of course, I mean, this is a bit too broad for an actual production website and so on, but just for testing for now, for the moment, that's good, okay? And again, we will discuss this in more details during the next lecture, next Monday, right? Yes. So just to check if I'm telling the truth, let's have a look at the server index.mjs. You see there is this import course. Of course, that's a module that helps us with this course, and we just tell app use course and allow any course request. So any request that goes to another server is allowed for us. Okay, good. Okay, so that's one point I wanted to underline, and again, we'll discuss soon the implications in terms of security. Second point I want to underline. We used an async function in the useEffect. Actually, you saw that, we actually wrote the definition of an async function, and then we called the async function. I mean, couldn't we write like open the bracket, async, open, closed, arrow, and so on? No, unfortunately not, okay? That's a sort of small limitation of the useEffect hook. You cannot pass an async function directly, okay? So, you need a reference to a function, okay? That's because the function has to be called later. If you pass an async function, okay? Maybe there are some problems in handling the function in useEffect for some reasons. I cannot exactly tell you why, okay? But that's written clearly in the documentation of the useEffect. And actually, it's not so big limitation. Indeed, we already circumvented that limitation because actually we went around by simply defining an async function inside the callback of the useEffect, and then at the end of the definition, we just called the async function, okay? So, easy to go around this limitation, right? So, it cannot be an async function, the function that you pass to the useEffect, but we are in JavaScript. We can define functions inside functions. Oops, sorry. Inside functions, okay? So, just open a normal function, makes the useEffect hook happy, and then define the async function, call the async function, okay? Why do you need the async function? Well, because we wanted to use the await, okay, which is so convenient. Otherwise, we can also get rid of the async function, just call fetch, etc., then, and so on. That's the alternative way of writing something that depends on promises, right? Doing a chain of then, catch, and so on. That's an alternative, a good alternative as well. I mean, I prefer to show the await because it's shorter on the slide. It's easy to understand. We wait until the return value is available and so on. Okay, but I mean, not really needed to use async await if you don't like them. Also, you know that it's more difficult to handle rejected promises and so on. So you need to have the try catch. With the dot catch, it's easier and so on. So you need to decide what is better for you. Okay, third point. I didn't tell anything about the return value of the callback. I just used the callback. I didn't return anything. So you know the JavaScript returns undefined when you don't return anything. That's what we said in the first lecture. But actually, some side effects need to have a cleanup, to clean up things. Let's assume you set a timer. You destroy the component, so the component gets unmounted by React because you change page. The component is not visible anymore. There is a timer, it has a callback that will set a state. It will set a state on a component that doesn't exist anymore, okay? React gives you an error because, it doesn't know what to do. How can I set a state that doesn't exist? That's a problem, right? So, React recognizes these issues and gives you a way to clean up these side effects in advance, okay? And the way is the fact that you can return a function from the callback that you pass to the useEffect. The callback here, the callback here, empty parameters, side effect, and so on. At the end, you can return a function, clean up, that does what you need to do, like reset the timer, reset the interval, stop the request, stop the fetch request, and so on. Whatever you think it's appropriate, okay? React, when you call the useEffect during the render, just as it stores the callback, okay, it will store later the returned function from the callback to be used at the next interaction with the component, okay? So if the next interaction is, well, it will be used in any case. At the next interaction, before using the callback, it will execute the cleanup, okay? And this also means that when the component will be unmounted, it will not run the callback again, but it will run the cleanup. So you don't incur in this potential error, this potential mistake, okay? So, in short, what you return from the function, so the callback that you pass to the useEffect is a function that is used in this way by React. After the initial rendering, useEffect invokes the callback, and the cleanup function handler is kept by React but not invoked. Okay, it's not used in the beginning. It's used the next time you call the useEffect. Okay, on later rendering, before invoking the next side effect callback, so the next useEffect, the useEffect invokes the sorry, not the next useEffect, but the next side effect callback, so in the commit phase. Okay, the useEffect invokes the cleanup function from the previous side effect execution. So it stores the reference to this function that you passed in at the previous step. It cleans up everything, and then it runs the callback. Okay. Finally, after unmounting the component, so you remember the state machine, right? After unmounting the component, React knows there is still a cleanup function to be run, and it runs this cleanup function. So you, let's say, reset this behavior that is doesn't make sense anymore. Okay, like setting a state on a component that doesn't exist anymore. Okay, good. So I must tell you, this behavior is typically not that much used, unless you really need to, how to say, you really need to use intervals or timers, so something that is automatically executed by the JavaScript environment. You probably don't need this cleanup function. Okay. Okay. So just make sure that you know, okay, because it seems that the AI tools like to use it a lot. Okay, so I mean, this is just a warning. Unfortunately, I mean, at least last year, it was a sort of frequently asked question at the exam, because very often if you ask an automatic tool to code something for yourself, I mean, tools like to clean up things very, very well, right? I mean, closing files, resetting timers, and so on. Okay? So if I spot, and my colleague spots a callback, I mean, a function returned from the callback of a useEffect, we will for sure ask you, why did you use it? Why it was necessary? When this function runs, and we said when this function runs, why it is needed in your case, what happens if you didn't do, why you inserted it, and so on. Okay? Recognize which variables, if any, are part of the closure of the function. But I mean, this closures happens everywhere in JavaScript. So I mean, we should probably ask you, is there a variable that is not part of a closure here? Because I mean, sometimes, I mean, in short, basically everything becomes a closure in JavaScript, because you define a function, if you don't call them immediately, everything becomes a closure. But I mean, let's put this story of the closure aside. And I mean, it's important that if you return something from the callback of the useEffect, you know why, and hopefully you know, I mean, there is a reason why you did it. Okay? I mean, in principle, it's not wrong. It's also, let's say, good if you write a good code. But I told you, I mean, typically you want to do cleanup only when there are timers or intervals involved, okay? Because they happen quite a lot. They might happen quite a lot of time after after rendering, okay? And so just make sure that you know what you did, okay? That's a summary of the slide. Just a few more words about what we saw before. User interaction and slow API calls. You saw that we had a server, slightly modified server compared to the slides, because there was this random delay on the server. Now we'll go and have a look at the code. But I mean, well-designed application always show a consistent state to the user. If they have no data and user action should wait, they'll tell the user in some ways. I mean, the simplest way are these two. You saw the clock symbol, right? Or you saw this, you can see the spinner, you see the hourglass, all these kind of symbols that tells the user, well, sorry, you must wait. Sometimes there are animation with empty content and so on. I mean, we are not asking you to do so many fancy things. I mean, a string with loading is still fine, okay? But another thing, another interesting thing is disabling parts of the user interface that shouldn't be used, okay? Again, until the action has finished, okay? Like you say something, you shouldn't be able to press again save, store, or add, and so on, until the current action has finished, at least in principle, okay? It depends a lot on the logic of the application. It's like when you pay, you say, okay, I have the cart is full of items, I'm ready to pay, okay, let's go to the page where you can put your information for the payment, and then there's a button pay. Somebody says, just wait, don't leave the page and so on, don't press it twice. Well, don't press it twice. I mean, it's so easy. I mean, you disable the button, right? If you don't want the user to press it twice, disable the button. Okay, so easy to do. There's the state, pressed and not waiting, not waiting, like we saw before. Okay? But, I mean, be careful. This is a trade-off. Because, of course, any action the user does, you can disable the whole interface, wait for the update from the server, and then re-enable everything. That's the limit case, right? It's too much, probably. On the other side, I mean, it's quite difficult to disable only the single feature that should be disabled when you do an action, okay? So you need to find a reasonable compromise for the submission. I mean, I mean, in practice when you develop web application, but speaking very practically for the submission of your exam, okay? So now we'll try to revise the example we saw until now. So this flipped text example with these ideas in mind, okay? So, let's revise the previous example. What happens if an API response arrives not in order, for instance? You see, you type and something happens. So you press a character, you don't have to submit anything, right? And so there might be issues in this regard. Because, of course, now we have a library, the delay is artificial. But if you interact with the database, or maybe you interact with different servers in different places, I mean, the order of the response is not guaranteed. So you need to be careful that your application works well in any case, okay? So basically we have two ways of handling the situation now in our simple example. Fixing the issue without blocking the user input. This is the most difficult solution. I'll give you the solution, but it's not required for the exam as it's written in the slides. Or maybe we can change the way in which the user interacts with the application. And might be an acceptable compromise. You need to think a little bit about the usability of the application. Okay? If it's a quick operation, you save and you disable a button for a while, that's fine, okay? So just not to repeat the same action again. But you need to introduce a button, okay? Before, we didn't have a button, right? So let's try the example and see how what happens and what's the problem, right? So let me clean up everything. So let's reload the application, okay? So we are focusing on the flipped text. You see A, B, C, D, E, F, G, H. You see that you know, the response here for the flipped, it changes quite a lot, right? Let's try again. You see, because the time that the server takes to give the answer is random, okay? Between a minimum and a maximum. I didn't want to have 1 minute, of course, right? But I mean, you see that again. So that's not a behavior we would like to have, right? I mean, it's not nice. And by the way, are we guaranteed, I mean, do we guarantee that actually what we see is actually correct? Yeah, probably yes. I mean, but we should check, okay? So the problem is that as soon as you change something, you have the handle chain. The handle chain changes the state. The state is in the dependency array of the useEffect. The useEffect immediately issue a fetch. And that's fine, okay? But the point is that you resume executing the rest of the code depending on when you get the answer from the server. It may be early or maybe later than what you expect, okay? So answer can come back not in order, okay? Here, unfortunately, we don't see the order of the answer, we see the order of the request, okay? But you can see, oh, maybe there is a drawing somewhere, I think, I'm not sure, that gives you the timing, not sure. Yes, that's a timer for the single one, but, well, let me see. I don't remember if there is, there should be one. No throttling. And anyway, it doesn't matter. I mean, yeah, it's here on the right. I think it's because it's too big. Yeah, you see, that's the timing. Okay, some requests are answered more quickly than others, okay? Now, yes. Okay? We should be able to handle these situations. Okay, so what can we do? I mean, at the moment, I mean, we do nothing, right? Because we have a callback queue. The code is stopped there, waiting for the fetch. The fetch gives back a settled promise when it gets back something from the server. And then, depending on what the server does, we have these operations that, set the state of flipped, that is the state that decides what to show here, depending on what you get here, okay? Okay. Good. So, let's see the more complex solution first, but because I don't require and don't expect you to use it at the exam, okay? Not required at the exam, because, I mean, honestly, it's difficult, and doing it for all the requests to the server is very, very complicated, okay? But if you go to the React documentation, that's, what they suggest you to do, okay? So it's not something I invented myself, but something that maybe in practical application you should think about, or maybe you should search for a library that helps you to do these things more efficiently, okay? Okay, so what do? Well, basically, they make sure that you ignore all answers, all values returned from the fetch until you get the latest one, okay? So they use this cleanup function, okay, which is difficult, of course, okay? And so basically they create a variable ignore false, okay, before running the fetch, and in the cleanup function they write ignore true, okay, and this ignore true, now there is an ignore variable for each time you use this callback, because this callback is recreated each time the component is rendered, okay. And so how does this work? Well, when so the set, what is this? Yes, it's used here. If not ignore, okay. So so in short, if ignore is false, okay, so nobody has changed this ignore, you do the set, so you do the change of the state, and so you do the render. Otherwise, you skip this update of the state. Why you skip it? Because it means there is another callback in another useEffect. There's a set, the ignore, this callback has already been executed, and there is another callback to be executed before running the new callback. The cleanup function of the previous callback will be executed. So this ignore is set to true. And so it makes the previous callback of the useEffect skip the set flipped. So it makes sure the set flipped is called only when the callback of the useEffect is the last one that has been run, okay? Because all the others have been affected by the fact that this cleanup function set the ignore true, okay? And now there is an ignore for each one of the callbacks. This is the classical place where you have this closure, right? Because the ignore is the one that you define here inside the function, okay? You pass it, and you create a function that has a closure exactly on the ignore of the callback you just created, okay? Oh no, you need to think a little bit about this example. I know it's not simple, and that's why it's not required at the exam, okay? But we can test it. I mean just out of curiosity, I prepared it, last response, okay? So let's flip the last response. There is this ignore and so on, the code that you see on the slide. How do we test it? We change up, right? So, last response, okay, I remove the comment, and let me reload the application. Oops. So actually we don't use the one on top, we just use the one in the bottom. You see, now it works, right? Because only, the function that arrives at the point where you need to set the state, that has ignore equal to, what was it? That has the ignore equal to false, will set the state, okay? Because nobody has reset it before. So nobody has done the cleanup, so has finished before. We know it's, I know it's more complex, okay? But you need to keep in mind that you deal with servers which are unpredictable. That's the purpose of, attending this course, understanding web applications, not just about understanding React. This is a property of any web server, web API server, and so on, okay? They are unpredictable in terms of response time and so on because of the server and because of the network, okay? And so these race conditions may happen. They actually happen all the time, and sometimes websites don't work. They don't work because the programmers, the developers didn't care enough about these conditions, okay? So let's go back to something you can do for the exam instead, okay? So fixing the situation I mean, the issue that we have is not easy. I mean, we should change the user interface a little bit. Instead of, you know, sending immediately the request each time you change a field in the form, you can add a button, update, send, whatever, and disable the button until you get a response. Okay? Of course, the user interface is a little bit different. You should check if it is allowed or not by the specifications that you have about the application you need to develop. So for the exam, maybe you should ask, I mean, the teachers, because they are the ones who give the specification. You are developing the application for somebody. I mean, make sure that this somebody has, I mean, likes this kind of web interface, this kind of user interface, okay? I mean, Google didn't like it, right? Because when you type on Google, you don't have to press anything, right? Google.com, A, B, C, D, oops, sorry, D, E, and so on, okay? And they make sure that you get something that is reasonable. So they handle the issue, okay? And then you also have the button that, okay, that's another story. Okay, so if you change a little bit the user interface and you disable the button, well, you don't risk that the user send a request for which you don't already, I mean, while you're waiting for an answer for another request, okay? So let's have a look at the behavior and then we look at the code, which is much simpler, of course. So we uncomment the text flip simple, right? So let's reload the application. Sorry. Okay. The first one is the simple. You see there's the, there's the update button. A, B, C, nothing happens until you press the button. You will see that the button becomes disabled. Okay? I press it twice after. But until I got the answer, the button was disabled. Okay? Click, 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 but nothing happens. Okay? This prevents from the user from sending more than one request until you don't get the answer from the server. Of course, I mean, the user interface, the user experience is different because you need to wait for the answer of the server. Okay? You have a Google Doc, you are typing, you cannot simply wait for Google Doc to save what you wrote, because blocking the user from typing. Worst user experience, right? And indeed, in Google Doc, you see that on the top there is saving. At a certain point, you stop at typing, you say saved. Okay, so they handled the user interface in this sort of way. But of course, you know, not blocking the user is more difficult. Blocking the user is easier, but it must be acceptable from the point of view of the user. Okay? Let's have a look at the code. No, let's stay on the slides. I mean, the slide is simple enough. So, you see, in addition to the previous case, button disabled waiting. If we are waiting, just disable the button. So simple, right? This is not about security issues, okay? This is about user experience. Because if you send 3 requests to the user, I mean, you cannot, I mean, you can even send them, but if the, I mean, your application will get the answer from the server only through the code that has been written here. So, I mean, it's about loading the server, but it's a server issue. It's not about the client issue, okay? So you're not messing up with the client, and if you're messing up with the client, of course, you might expect that things work differently, okay? So from the point of view of the user, it's just about user experience. He has to, or she has to press a button and wait, okay? Because you need to understand first when he or she finished typing, and then you need to wait for the response, okay? So this is what we call a reasonable compromise for good exam evaluation, okay? Unless something different is required, okay? It might happen that, I mean, we would like to have a form where we type things and as soon as we type, as soon as we do something, the user interface shows what comes from the server and so on. Typically, we will say this explicitly in the text, okay? And if you are in doubt, you will ask, okay? Don't worry, I mean, at the first and second exam seats or second exam course, call it as you like. I mean, many people do, pose questions, okay, before the submission deadline. But that's normal, okay, because everybody has its own interpretation of the text, okay? We start with our interpretation. Me and my colleague, typically we compare our interpretation together, but we are a little bit biased, right? And so just try to think of what you would like as if you were a user of your application, okay? Would you like an interface that behaves like this and, or like this and so on? But be aware of the fact that this is much more difficult to handle, okay? And what I would say is I would avoid the middle way because, it doesn't look so good, so efficiently, right? So you remember here what it happened, right? I mean, I'm not doing anything. I'm just getting random stuff shown in the user interface, okay? Probably not the best thing. Remember the other one. Maybe I'm waiting more, but I get the final answer, okay? Okay, good. So this is really, important, not really because we like, that you focus on this sort of minor points, but because this course is supposed to give you the basis of web applications, user interaction with web applications, and then discussing some of the issues that might happen also in terms of security with web applications, okay? And so we would like you to spend a little bit of time about thinking about the user interface, okay? Okay, good. So find a reasonable compromise between blocking and usability, okay? They are opposite, because usability is the best if you are never blocked as a user. But blocking is the easiest way of handling things in programming, okay? And typically try to inform the user of what's happening. Google says, Google is just an example, but any well-designed interface says what's happening. There's a spinner blocking everything because you need to wait. You're paying with a credit card. You cannot do anything else. They tell you, wait. Okay, that's an important operation, you should wait. You are just adding a thing in the cart, maybe, you don't care that much if it appears now, a little bit later, and so on. When you refresh, it will appear, okay? If it didn't appear, you add it again, okay? It depends on what you're doing inside your application, okay? So, in priority order, I would say disabling part of the user interface that might lead to situation difficult to handle. That's probably the most important thing you should care of. And then, well, there is also the loading, but loading is not really fundamental if typically the waiting time is small, okay? You are almost a computer engineer, maybe you're already from 3 years, bachelor, computer engineer, and we know you are fast. People is fast, but people is not so fast. Generic people is not so fast when dealing with user interfaces. Okay, so waiting a little bit is sort of normal. If you wait too much, people start wondering what's happening. If there is no clue about what's happening, the application is doing something and you should wait, it becomes a problem. Okay, so at least you should prevent user from doing things that leads you to a situation difficult to handle. Okay, last point, almost last point, okay? You saw that in the beginning, the useEffect did the operation at mount time twice. You remember it? Maybe not. We see it again, okay? So, console, let's reload the application. You remember the my static number 3, dynamic multiple true. Okay, and then that's in gray because I don't know why Firefox likes to put this in gray. But I mean, there is the same printout, right? The same console log. So it's like the callback at mount time has been called twice, so 2 times. Actually, that's exactly what is happening, and this is the reason we have put this in the slides, because it happens so often, and we want this to happen at the exam as well. Okay, we have the strict mode active in React, that is in development mode. Okay, React in this strict mode runs the setup and cleanup callbacks functions of the useEffect one extra time before the mount of the component actually happens. And this is a sort of stress test that verifies that everything is working fine. If your web application is not working correctly just because of the reason there is something wrong in your application code, okay? So if this causes any issue, there's something wrong in your application code. Either you should use a cleanup function, or you should do another kind of operation at mount time, and not an operation that cannot be repeated, and so on. Okay? So rule of thumb, very simple rule, a user should not be able to distinguish between the effect being called once or twice at mount time. This is just for mount time, of course. You know, while you are re-rendering the component, this does not apply. But the mount time, this applies. Where is this strict mode set? This is set in the main JXX. You see the strict mode. It's put there by White, okay? And we don't want you to remove it, okay? Leave it as it is, okay? We know that at mount time, things will happen twice on your components. Not just at mount time of app. That's, of course, that's the first component that mounts. But then you have pages, you have routes, and so on. Every time you change route, maybe you mount a new component. When you mount a new component, this component will render twice, and we run the useEffect at mount time twice. This shouldn't be a problem. If it's a problem, there's a problem in your code, okay? So you're doing an operation which is not supposed to be done at mount time. Okay, and if you have any questions, feel free to ask. We have the labs or during the lectures, the breaks and so on. But this is why we want to keep the strict mode active, so you also detect potential problematic behavior. And this is a cost, of course, in production. In production, this is not done, okay? It's just called once. Nothing should change when you move to production mode in your application. What's the time? Okay. Note that, today we have talked a lot about useEffect. We expect that you use the useEffect for the submission of your exam. I don't think we ever saw a submission without a useEffect, because you need to load data from the server in the beginning. So at least one useEffect at mount time must be present somewhere, okay? But remember that I also saw submission with like 15 useEffects. That's probably too much. UseEffects are not really something that you want to use every time, okay? Because they reduce the purity of the component, they go outside the way in which components have been designed, pure function and so on. So use them when you think it's appropriate, and maybe think if they are actually really needed in any case you want to use it. Okay? I mean, I think this year we will question you quite a lot about these things. I already questioned during the last years about sort of each use effect, why it was used for, and so on, okay? But I would say this year we will pay even more attention, because many times you use a use effect just because you want to update a local state depending on a process that is being passed, okay? And that's not a good way of using the use effect, because it creates a lot of implicit dependencies that are difficult to track, difficult to debug, and so on, okay? You create a sort of internal state machine that you don't understand, we don't understand, and in general it's difficult to maintain. So two common cases where you don't need an effect, a use effect. Transforming data for rendering, okay? I mean, you already did the lab with the films, and there was a filter to apply, okay? I hope nobody of you has used a second state with a second list of films, okay? It's possible to solve the problem in this way, with a filtered list of films. I have a state with a whole list of fields, I have a second state with a filtered list of fields. But to keep the second list of films updated, you need a use effect that depends on the filter, because you need to set a state on the previous one when the filter changes. And that's not a good way of writing the code, because you have two sources of truth, okay? And it becomes difficult to maintain, introduces dependencies, and so on. I mean, when you have a value that depends on you know, another one, just do some computation. You write a function. You take the list of fields, you take the filter, and you get the filtered list of fields. You can do it at every render. This is fine to be introduced in the code of the component that renders the films. You get the state that is the filter, you get the state that is the list of films, and you determine which films you want to show. Okay? So this is transforming data for rendering. Okay? Handle user events. You saw you set yeah, like the flip text, okay, with the update button has no use effect, okay? So if there is no need for the use effect, just don't use it. No, let's go back. You see, no use effect. There is no use effect around here. You can start an asynchronous operation from an event handler. That's perfect. Perfectly fine. Easy to understand. User click the button, you started fetch from a server. Perfect. The button can be get information, store information, save, delete, and so on. Perfect. Okay? No need for the use effect. You don't have a list of dependencies. You don't need to do anything at mount time. Just you need to do something when an event happens. Write things in the event handler. Just don't do a thing like, I mean, the alternative would be that I don't want. Alternative would be user creates an event, you set a state, there is a use effect that depends on that state and starts an action. Okay, that's an additional level of indirection. Okay, and something that I mean typically is not useful. Okay, just complicates the code, becomes more difficult to debug, etc., etc. There can be cases. We will see one case, okay, but much later on. I mean, like I think so. Oops, where it is? Like something like this, okay? Just for curiosity, you have a component mounted depending on the URL and so on. Might be a good idea to do this operation, okay? But very specific case, okay? In general, you have an event handler. Don't set a state to trigger a use effect, okay? That's a message. Don't set a state to trigger a use effect. Unless, I mean, this state is already present and maybe you need for something else and so on. So there is actually a reason to set this state, okay? But, I mean, even in this case, you could make a function and call this function both from the event handler and the use effect, okay? So you don't really have any need to start the use effect. So in short, only code that runs because a component was displayed at mount time should be in the callback of the use effect. The rest should and can be in events, okay? And there is a big, a long page in the React documentation that tells you all the cases and how to remove all unnecessary use effects, okay? I mean, it's not that we don't like use effects, but we don't like too much use effects because they make the code much more difficult to maintain, okay? And that's why also it's a good topic for the discussion at the exam. Of course, when all the things work and there is nothing else to discuss and so on, so it's basically discussing about how close to the maximum grade you can be, okay? So summary, 4 ways to call the use effect, and then we will code an example, okay? Very simple example starting a fetch request at mount time. So, use effect, you call it, you call the callback once when the component mounts. Most common example, you for sure have one in your submission for the exam. Empty array. On every component render, very unusual, okay? Because almost as writing the code in the component, I mean, but we don't want to do it because it's a side effect. On every component render, if some values changed, okay, that's normal. When the component mounts, remember that you can return a cleanup function, just in case it's needed, okay? We saw an example. There are many more hooks. It's very small, it cannot be selected, it's just an image and so on. I don't want you to use them, okay? Don't use them. Don't use them because, typically they are just used by the AI coding systems and so on, and I will question you, why did you use them? There's no need in our simple examples to use these hooks, okay? They are just for more advanced functionalities where we don't need, that we don't need in our applications. Okay, so let's be quick. So now we would like to handle some API calls, and just the first simple one, loading initial data, okay? So, we'll come back to this next time, but here I want to show you that we have this conceptual architecture. So the left, the blue one is the client, the right one is the server, right? Server is already ready. We prepared it during the 3rd week of this course, okay? There are routes and we can get information, we can store information and so on in the database. JSON and so on, we are missing what? Something that connects our React components can handle the fetch, okay, correctly. So we are trying to write something here, okay, in the API. So some code that handles the API, runs this fetch and gets the information and set it into a state. Now that we have the state and the use effect that allows us to run some code at mount time. Okay, so this operation is called rehydrating, getting the state from the server through API, through HTTP API HTTP calls. And the best place to do it is inside the use effect that has an empty array as the dependency list. Okay? And we try to do it now. Okay? So we almost did it. Actually we saw an example with the flipped text, but there was a dependency. And now we try to modify our example, that is the one here with the React QA. So this is the one with the router. Okay, so let's stop everything. we need to move to the other folder in React QA client. That's the client. We need the server as well, okay, for later. React QA server, okay. I'm not starting the server yet. Client must be installed, clean install. I can run the client. This is still not asking anything to the server. It's the client that we had last week. Run dev. Open. So that's the stuff that is not doing anything apart from changing the local state. If we reload the application, start from scratch. But now we want to load the information, not from a pre-coded stuff, pre-coded information here in the client code. So you remember that we have this question, new question, question init, and so on. That basically goes and defines everything inside the code, right? We don't like it anymore. We have a server, right? Actually, the server is what we already developed during week number 3. You remember the server had get API questions, get API questions ID answers, okay? I think this is the full server. I mean, it doesn't matter. So here we are in the server. npm clean install. Oops. That's because sometimes you create a package on the Mac on one platform and you want to use it on another and so on. It might happen to you as well. When this thing happens, just remove the package lock.json and install normally. Okay? npm install. Okay? Not the best thing from the point of view of security, we know. But I mean, we are not an organization like Meta, Google, and so on. We have no private repository from which we know we can load packages and so on. So I mean, we need to find a compromise. This is a 8 credits, 8 CFU course. Okay, so we need to, let's say, accept some compromise. NodeMon index MJS. Localhost 3001. Okay, server, there is, you want to test things. I mean, you remember the, what's the name, REST client, right? That's the same. API questions, 1 answers. Okay, so the answer to question number 1. That's a response in JSON format. Okay, so that's exactly the server that we developed in week number 3. And now we need to connect it, right? So let me close some windows. I think this one is, yes, it's the one of our application. So now we have a list of answers, right? So that is an initial answer list. This initial answer list is used as an initialization of a state in app answers. Okay? Let's change this behavior. So, how do we load this, this information? Well, actually, we can go and ask the server when we are at mount time, right? So, how do we tell we are at mount time and we want to run some code? We have the useEffect, right? Okay? So, useEffect. Then that's wrong. Okay. useEffect, dependency list, empty array. It runs at mount time and only at mount time. And then we can write something inside here that will finish with set answer, okay? And then we decide what to write inside. But that's the purpose of the system, okay? So, useState, initial answer list is empty, okay? We don't take the stuff from the code anymore. because we get it from the server. We will have a first render in which the list is empty, but then immediately, as soon as the server answers, the list will be re-rendered with the content coming from the server. Okay? Good. So, what are we writing here? Well, we should do the fetch and so on. Right? Fetch HTTP localhost 3001 and slash, what was the name of the API? API questions, 1 answers, and so on. Okay? And then you get this information, an array of objects, etc., etc., etc. JSON stuff, right? It says here, application JSON. Good. And so we should write some code, which I already wrote, just to speed up, the example. But also because I recommend you to keep this code isolated from the rest of your client application. You see this API.js, okay? This API.js is just, another module. It doesn't deal with the JSX, that's why I called it JS. Not really mandatory, but, just for, to have things, to make things clean, okay? So this is just code, JavaScript code, okay? Not dealing with JSX, not dealing with React. And get answers by question ID. I pass an ID. It goes and does await fetch URL, which is localhost 3001 API. Questions ID answers. Parses the response in JSON format. It creates something that is useful for me. Okay, ID, text, responded, score, day.js. It creates the day.js object. I'm expecting a day.js object. Somebody has to create a day.js object. JSON only transfers strings. So I need to define a format for transferring the dates. You saw it before, which format we used. Where is the server? So there's a format. One of the possible formats. We decided to use, I don't know, that's the ISO format, I think, something like this. I don't remember. The important thing is that something that can be easily converted and created. Okay? Just define a format. It's up to you. And if response okay, return answers. Otherwise, throw answers. So we create an exception because we have the await. So this is an async function. It's a rejected promise and so on. Okay? So just use it. API dot get answer by question ID, question ID. What's the question ID? Well, at the moment it's just 1. Okay? Save. Let me import the API. Okay? Don't forget to import it, right? Import, I think it was API. Yes, from API. It's another module. Okay? You need to import it. Even though the AI is suggesting a lot of things, but it was not imported yet. And then, actually, it was right. It's a promise. Then answer, set answer list. Yeah, I think I used the then, right? Yes. So, .then, set answer list. At the moment we don't have anything to catch the error. I don't want the alert. I don't want to see the alert in the exam submissions. Okay, so the set answer is already here. Okay, save. Let's comment. Well, it's already grayed out, but let's comment the initial answer list so we are sure we are not using it, right? Let's try the application. There's always something wrong, okay? But we don't care. So let's try to load it. Doesn't provide an export name API. Oh, sorry. It's probably I didn't export things Export default API. Okay, so I think we need to import it in a different way. Import API, right? Yes, okay. You saw? It was empty, it became full of answers, right? So let's try again. It takes a while to get the answer from the server, okay? That's normal. It's fine, okay? You can see it during the in the network tab. You will see the request. If you don't see the request, that's an issue, right? Get ATP localhost 3001 API questions 1 answers. Okay? Actually, you see 2 of them because I just told you for debugging purposes in strict mode React at mount time of each component it performs the action of the useEffect twice. Okay? So the time is here. Okay. Yes. Let me do the. We will finish next week, of course, because it takes time to develop this stuff, because we need a lot of concepts. But I mean, we can introduce a state waiting. Okay. Just to show you how can we handle states depending on what we get from the server. Const waiting or loading. I wrote waiting, so waiting. Okay, in the beginning it's true. Then, yeah, set answer, set waiting false when we get the answer. Okay? Okay, and don't forget to set false in any case, even with errors and so on. Otherwise, the interface gets stuck. So waiting could go into a finally also. Okay, but I mean, for the moment, it's fine. We need to use the waiting. Where do we use the waiting? We need to render something instead of the empty list. Okay, I think it's here, right? Waiting. Waiting. Yes, that's too much. Spinner. I think that's enough. Or, I mean, answer route. Okay. Save. Spinner is. It's already here. It's from React Bootstrap. It's just a nice animation. Let's try. Okay, very simple. A state set to true in the beginning, reset when we get the information from the server. You know, looks like a professional application, right? I mean, of course, graphics can be improved, the layouting can be improved, all these things, but maybe you want to follow attend a class about user interfaces, not a class about programming web application. So that's all right. I mean, of course, I mean, we can improve the code. We can move the waiting into a finally, just to make sure it's always executed, because otherwise we get stuck with the loading. Okay. We can load the questions as well, because we have an API to load the question. How do we know which question we would like to load? Well, either we ask for the first one, or we need to give an ID, okay, as I did here, and so on, okay? For a question can be transformed into a state, and so on. So every data that you have in your application will be transformed into a state, and if it's necessary, it will be loaded when it's needed from the server using a useEffect callback, okay? That runs at mount time of the component. Okay, just last word. I mean, try not to load everything at once when the application loads. It's not like you open your Gmail and every email is loaded when you open your Gmail, right? As soon as you need the information, you can load the set of information that you need. Okay, that's a reasonable way of handling this interaction with the server. Okay? It's true that we can load everything at the start, especially in our simple examples. In our simple example, we have not so much data. It's local. It's a local network inside the computer and so on. Everything is fast, and so of course it doesn't make that much difference. But you're at the exam, you need to show that you understood the concept and you're trying to, design something that makes sense. Okay? And of course, if you have questions, comments, and so on, I will be present in the lab tomorrow and on Thursday in this room as well. Okay? So not my colleague, but it's me again. I'm not sure, unfortunately or luckily. It's up to you. It's up to me. I'm lucky. I mean, I like coming here because I want to see what you can do and what are the questions you have. Okay? So we can address them during the lectures. So I think for today, that's all. Okay? We had a long discussion, a small modification to our example, but next week, so 2 labs, and then next week, we will continue and address all the rest and make everything work. Okay? The delete, that is the simplest stuff, upvote, edit, etc., add, and so on. Okay? With the interaction with the server, so we reload the application, and this time it will be as we left it, because everything has been saved on the server side in the database. Okay? So if you have any questions, I'm glad to answer. Otherwise, I think we need to stop and we